when I have it set up like this, we can just easily use elimination, that technique to solve systems of equations. And that is when you basically just put a giant addition symbol and you combine them, but you make sure that one of your variables has coefficients that are the same number but different signs. So this is a positive 1, this is a negative 1. And so if I were to combine these two equations, 1z plus 1z is 2z. It sounds like I'm saying 1z, like a onesie. Like I wore a onesie last Saturday. Anywho, plus y minus y, that's just 0. So that's why they eliminate. And then I have 428. Now I have one equation with one unknown. And we can easily solve this for z. Z is 214. So now we know we can get rid of this variable z and say that this is 214 degrees. Therefore, what is y? Someone tell me, please. 146. How did you find that? Okay, and you took what value and did what to it? Yeah, 360 minus 214. So now, we figured out what these arc measurements are. How are you going to find the measure of angle 2? Someone remind the class how an inscribed angle is related to its intercepted arc. The angle of measurement is 1/2 the intercepted arc. So what's the measure of angle 2 finally? 73 degrees. This is a basic complex problem. You're going to try number 12. You're going to succeed and solve number 12. That's what you're going to do. You're going to apply this process to the parts in item 12. And you will conquer it. Quickly go over these parts here. So A and B are asking for the measurement of these two arcs that completely make up the whole circle. So we know that when you add them together, they're going to equal 360 degrees. But also, the measure of angle P, which was given to us 16 degrees, this angle is outside of that circle and it intercepts these two arcs. So I know that 16 is equal to 1/2 the difference, and I'm just going to call this, we'll use the notation, WIE minus, and then minor arc WE, the measure WE. So that's one equation that we know about those two arcs, and the other equation is that I know the measure of arc WIE plus the measure of arc WE equals what? 360 degrees. So this is exactly the way that we set up the other problem. So we set up a systems of equations. I'm going to multiply both sides of this first equation by 2. So I'm going to get 32 is the measure of arc WIE minus the measure of arc WE. So now this is a systems of equations with two unknowns. So I'm just going to combine both of these, and when I do that, this unknown, this variable, eliminates. That is elimination. So this would be 392 equals two of these measures of major arcs, WIE. Is anyone else on the same page? We okay?
Yes.
Sweet. Divide by 2 on both sides, and we get that the measure of the major arc, WIE, is 196 degrees. Therefore, how can you find the measure of angle of arc WE? Subtract by 360, so 164?
Yes, 164.
164. 196. Okay.
I say that arc AM is the most easiest one.
Okay, let's see what happens. So we're also told that arc CO, so this guy right here, this was given to us as 96 degrees. I'm just labeling it right now. So the next angle is the measure of angle OAC. Well, angle OAC is this guy right here. That's an inscribed angle because the vertex is on the circle and it's intersecting this arc that is 96 degrees. So the relationship between that and the intersected arc is it's 1/2. So that's very easy. This is 48 degrees. From there, the measure of angle MOA and arc AM. We first need to find the measure of arc AM. So if we're looking at this angle that's outside the circle and the large circle, I know that this angle measurement is the difference of the two intersected arcs. The difference. So we take 96 minus that. 1/2 of that difference is going to equal to 16. So we got 16 is 1/2 the difference of 96 and then the measure of arc AM. So that means 32 is equal to 96 minus the measure of arc AM. When you solve for the measure of arc AM, you're going to get 64 degrees. You just solve and get the 64. That's just basic algebra. Now that we have this intercepted arc, we now can see that the other angle that they're talking about, this guy right there, that's intercepting, angle MOA is intercepting this arc that is 64, so it's 1/2 of that, 32 degrees. We already figured this out, this is 64. The measure of angle C and O. C and O is an angle whose vertex is inside the circle but not the center. When that happens, this angle is 1/2 the sum of these two intercepted arcs, because you have to look at both of them, because those are vertical angles and they're going to be congruent. So it's 1/2 the sum of the two intercepted arcs. So the measure of angle, I'm trying to find, okay, C and O is equal to 1/2 the sum of 96 and 64. So the measure of angle C and O is equal to, this is 160, divided by 2, you get 80. So that angle would be 80 degrees. I know there's one more part, we can talk about that next class. However, I want to look at your notes really quickly. Pull out your notes and go to the last page. We're looking at our notes on the very last page. Up at the top left, you see a diagram of a circle with two intersecting chords. And I'm just going to relate this to something that we have already seen before in this class. Don't do it quite yet, but if I draw in these auxiliary segments and then I outline those chords, we have a diagram like this. We know that vertical angles are always congruent. And if I told you that that angle was congruent to that angle, then what could be said about these two triangles? Similar by what? Angle similarity. And if triangles are similar, then what's true about their side lengths? Proportional. So that means when I compare A to C, because A and C, these two sides are corresponding, and D and B, because those two sides are corresponding, look at the congruent angle measurement markings. This D is in between 1 mark and 2 mark. This B is in between 1 mark and 2 mark as well. So I'm just matching up those sides according to the angle measurement marking. Then I can take the cross product of this. A times B is equal to C times D. Back to the circle, A and B were the two pieces of that same chord. So we're taking the product of them. And apparently that equals the product of the other pieces, the pieces of the other chord. I know that angle, this angle B and angle D are congruent because of that theorem we talked about at the beginning of the class. They both intersect the same exact arc. Look at the very, very top right. This is our theorem that when two chords intersect in a circle, then the product of the lengths of the segments of one chord equals the product of the lengths of the segments of the other. This is Mr. Niven's version. Product of the pieces. I have one chord here broken up into two pieces, 9 and 12. Is equal to product of the pieces. I have another chord that intersects. It's broken into two pieces, 6 and X. So when I take the product of those pieces, they're going to equal one another. So this is 6x equals 108. Divide by 6 on both sides. And we get that that is 18. Product of the pieces of the product of the pieces.